The powerful earthquake that struck Taiwan in April 2024 left a trail of devastation in its aftermath. While some buildings completely crumbled to the ground like an unstable house of cards, others were able to make it through the violent shaking without any signs of damage. This drastic difference raises a very important question. Why did some structures survive this disaster while others didn't stand a chance and collapsed instead? In this video, we will take a look at the factors that play a part in determining a structure's fate during an earthquake, and what types of designs engineers have come up with to give buildings a fighting chance to survive. First, let's learn a little bit about earthquakes. Earthquakes, which engineers refer to as seismic events, happen when the giant slabs of rock deep down in the Earth's crust shift and move. These giant slabs of rock are called tectonic plates, and when they move, it causes a release of energy from the Earth in the form of seismic waves. These waves can unleash powerful forces that cause a very violent shaking of the ground at the surface, which is what we feel during an earthquake. The intensity of shaking from earthquakes depends on several factors. First, the intensity is measured using something called the Richter magnitude scale. The higher the magnitude number, the more energy that is released during an earthquake, which also means the stronger the shaking we feel and the greater potential for damage to infrastructure. Another factor is how the ground shakes during an earthquake, which we call ground motion. The shaking can be vertical in an up and down direction, or it can be horizontal in a side-to-side direction. And this ground motion can be different from area to area for the same earthquake, depending on the location and distance from the center of the earthquake. The intensity of shaking can also greatly depend on the type of soil that sits below the ground. If the soils are really soft and not packed tightly, it causes the seismic waves to get amplified, and so the ground shakes even more. As far as buildings go, engineers can design them to withstand earthquakes if they determine that the area is prone to seismic events. But even if the best designs are used, that doesn't mean that a building is automatically completely safe from collapsing during an earthquake. This is because the workmanship and materials used during the construction of the building matters. And if it's not the highest quality, or the inspectors don't catch if something wasn't built according to the designs, the ability of the building to withstand earthquake forces may be at risk. Also, we have seen that older buildings were often built with outdated, weak materials before modern earthquake engineering standards were established. So, now that we have a good background on what earthquakes are and some of the factors that come into play in a structure's chances of survival, let's take a closer look at the Taiwan earthquake from April 2024. The magnitude 7.4 earthquake that struck Taiwan on April 3rd was the strongest earthquake in the area in 25 years. And even though the earthquake's center or epicenter was actually out in the ocean, it was just 11 miles away from Hualien City, and the shaking was felt across the entire island. Areas that were closer to the epicenter, in areas with softer soils or ones that had older buildings, experienced stronger shaking and more damage. And Hualien County was one of those areas that had buildings and infrastructure that were destroyed. Here, the older brick buildings were built on weak foundations, and when modern design codes were developed, these buildings were not updated. Even worse, if the buildings had known cracks or weaknesses in their structures, they were not repaired. So, they had less of a chance to be able to withstand a strong earthquake. Many of these buildings collapsed, and in some cases, residents became trapped and unfortunately didn't survive. However, Taiwan's capital city, Taipei, which is located further away from the epicenter, had less major damage to its structures. Also, since Taiwan is prone to earthquakes, stricter building codes were implemented in recent decades, and so there were more earthquake-resistant designs that were used, especially for these larger cities with newer buildings. These designs include things like reinforced concrete frames and stronger shear walls to help the building handle earthquake forces, using materials that can absorb the earthquake's energy and bend and deform without breaking, or building strong foundations that are buried deep in the ground for a more stable base. When buildings are constructed with these designs, it also does not necessarily mean they would be completely protected from earthquakes, but it does give them more of a chance to stay standing and maybe only have minor damage or cracks after an event. Taipei's iconic skyscraper, Taipei 101, is one of those buildings that is still standing tall following the recent earthquake. This building was the world's tallest building at one point, and yet, even though the building was actually swaying back and forth during the earthquake, there appeared to be no damage to the building. How this building did that was all because of the genius seismic design that went into its construction. The Taipei 101 building was completed in 2007, and when engineers designed it, they knew they wanted to make sure the building could withstand earthquakes. The super deep foundation of the building goes down an incredible 262 feet or 80 meters below the surface of the ground. This was to make sure that the foundation would be anchored firmly into the bedrock so that the building would have a stable base to prevent it from toppling over during an earthquake. The building was built with super strong concrete called high-strength concrete, which is a material that is known to be able to survive intense pressure and resist cracking during seismic shaking. The building's center core was also designed with a network of super columns and shear walls made of massive reinforced concrete, along with flexible connections in the frame to allow it to sway during seismic shaking without breaking. These parts of the structure act like the backbone of the building to keep it strong and stable when battling earthquake forces. Another important and interesting design feature of the Taipei 101 is that it has something called a tuned mass damper, or TMD. This piece is actually an enormous pendulum that weighs an insane 728 tons, or 660 metric tons, and hangs inside near the top of the building. This pendulum acts as a counterweight, which means that during an earthquake, it sways in the opposite direction of the building's movement. This opposite counter movement helps to reduce the building's overall movement, which minimizes the stress and damage to the building. During the April 2024 earthquake, there was a lot of footage captured of the Taipei 101 building swaying like crazy. Even though it seemed alarming to many, the pendulum actually helped to make the swaying motion controlled and predictable, and also sway within a safe range that would not cause damage from too much movement. This swaying was actually just proof that the seismic designs were working to keep the building standing strong. So, moving forward, this Taiwan earthquake serves as a reminder, not just to those in Taiwan, but all of us around the world, just how important it is to be prepared for earthquakes. Buildings that are old or not built to modern seismic codes, and especially those that are in earthquake-prone regions, should be regularly inspected and have maintenance repairs done to take care of any potential weakness points in the building. If it is bad enough, the building can undergo something called seismic retrofitting, where the structure is strengthened by improving the foundation, connections, or adding shear walls. And any new buildings that are designed and built should follow the most modern codes for earthquake design. Along with the design of buildings, there is also the public awareness side of things. If we can all understand how to stay safe during an earthquake, it can greatly reduce the risk of injuries and fatalities. And we should promote and support the continued research in earthquake engineering design, improving construction materials, and being more precise with earthquake predictions. The more we can do to be prepared for earthquakes, the better we can control the fate of buildings during the next natural disaster. Thanks for watching. We hope you enjoyed learning about the Taiwan 2024 earthquake and the factors that affect the survival of infrastructure during these seismic events. Be sure to check out our next video to find out how engineers know when infrastructure needs to be updated to withstand earthquakes and how they do it. And please remember to like and subscribe to our channel because engineering is for everyone.